Hello YouTube, in this video we're going to continue solving trig equations, and in this video we're going to focus on specifically factoring and factoring equations that are of a quadratic type, okay, and just basically algebra mixed in with our trig, but it's a good review. So let's go ahead and start by taking a look at this first example on the left here, which we're just going to use factoring, but it says solve this equation, and you'll notice that a few things going on here. First of all, it's a little bit more complex than the equations we've been solving in that there's multiple types of trig equations, or trig functions, excuse me. We have cotangents, we also have cosine, and furthermore we've got like a cosine squared. So when we solve this, an effective method would be to set it equal to 0, see if we can't get some factoring going on. So that's the method we're going to use here. And you know, as I subtract 2 cotangent x from both sides, basically, you know, I get this question a lot. We say, how do I know I'm supposed to factor? You know, it's just something algebraically you would necessarily try. So we have cotangent cosine squared x minus 2 cotangents of x equal to 0. And you'll notice that in terms of greatest common factor, both of these terms have a cotangent. So if we were to actually just take that out front here, we say, okay, well then we'd have, say, cotangent of x, and in parentheses this would leave behind a cosine squared of x minus 2 equal to 0. You'll notice now that we have an expression is like a times b equals 0, which is our zero product property. But if a times b equals 0, then either a is 0 or b is 0. They're both 0. But at this point, we could clearly just go ahead and set each of these factors equal to 0. And the nice thing about doing so is that we crank out a couple of equations that are very, very easily solved on their own. So let's go ahead and start with cotangent of x equals 0. To go ahead and solve this, we'll go ahead and take, we could necessarily say this. Cotangent of x equals 0. Then we say, okay, well then, you know, the reciprocal of this, we'd say tangent of x is equal to the reciprocal of 0, which is undefined. And so we'd say, okay, so if we did, say, the arctangent or tangent inverse of both sides here, this is really odd. But keep this in mind, you know, we say, okay, well, first of all, our tangent would cancel. We say x equals a tangent where we get undefined value. So we say tangent being y over x, we say, well, what angles could you take a y value divided by an x value and get undefined? And so that has to be division by 0, and the only two places those occur are these two quadrantal angles, pi halves and 3 pi halves. So we say, okay, so we've got pi halves, and we also have 3 pi halves. Now keep in mind, as in my last videos here, we say we want all infinitely many answers, so not only pi halves, but we say pi halves plus any period of a regular tangent graph or cotangent graph. We say so plus multiples of pi on top of this. These are all infinitely many solutions, these two listed here. Now moving right along, let's head over to our cosine equation here. In the last video we talked about solving this by extracting roots, and we can do this. We could say, well then cosine squared of x is equal to 2, and to get rid of this exponent of 2, we'll go ahead and take the square root. So we get this, we say cosine of x equals plus or minus radical 2. Okay. So in order to solve this equation right here, we could say, well then, you know, this is not a number that we're necessarily familiar with, but we'd say, okay, so we take the r cosine or cosine inverse of plus or minus radical 2, cosine inverse. And so this would be something we could necessarily do on a calculator. Why not? Why not? We say, okay, so cosine inverse, there she is, a cosine inverse of radical 2, enter. So we get a, okay, well, 50.5 degree angle, and we say we could do cosine inverse of negative radical 2. See, this makes a difference here. So we say square root 2, enter. Maybe. Well, it seems that we're gonna do the same thing. Obviously, now that I think about it, cosine is an even function, so it doesn't matter if we take the cosine of square root of 2 or negative square root of 2. We're gonna do the same angle, so about 50.5 degree reference angle. And so basically, we'd say any angle that had a 50.5 degree reference angle, 50.5, all 4 of these here. So didn't make up a very good example on this one, but that would necessarily be the case. We'd say, well then, our answers would be cosine inverse plus or minus radical 2. And we just use a calculator to kind of get those from there. Going along with factoring. Okay, so now let's take a look up here at the top right. We say equations of a quadratic type. I just want everybody to recognize, if you're watching this video, this is very much how we would solve something like 2x squared minus x to the first, 1x to the first minus 1 equal to 0, and that is to factor it. Same way we did this last one, except for the last example we used the greatest common factor, whereas here we're going to use two binomial factors. So in order to factor this, which is something we just need to be proficient with, we'll go ahead and start by saying, well, you know, in order to get 2 sine squared, we'd have to have 2 sine of x and sine of x. This is just a case. Those would produce our 2 sine squared x up front, and then we need to produce a negative 1 in back. So maybe you know, we go plus 1, minus 1. And so those definitely produce this negative 1 back here. So that all being said, if we check our outer and our inner here, we say 2 sine of x times negative 1 is negative 2 sine of x. And if we check our inner here, we say 1 times sine of x is sine of x. And if we add these together, we get a grand total of negative sine of x, which is the middle term. Yay! So now that we have these two expressions, or these two binomials, or the factored form of this trinomial, we can go ahead and set each individual factor equal to 0. So we'd say, okay, well then 2 sine x plus 1 is 0, or sine x minus 1 is 0. So we're going to fly through solving these ones here. We say subtract 1, subtract 1. We end up with then 2 sines of x equal to negative 1. And if we divide both sides of this by 2, then we crank out this. We say sine of x is negative a half. And then we can take the arc sine of both sides, or sine inverse of a half. Okay, so we're saying negative a half. Pardon me. So x equals, well, where is sine equal to a negative a half at? Looking at our unit circle, we say, well, it'd have to be in 3 or 4. And that looks like 7 pi 6 and 11 pi 6. So we say 7 pi 6, 11 pi 6. And we have to add on multiples of the period of sine. So plus multiples of 2 pi. Now, if we go over here and we add this guy, we say add 1 to both sides here. We say we get sine of x equals 1. If we take the arc sine of both sides, so sine inverse of both sides, sine inverse, then our sines cancel out. We're left with x equals sine inverse of 1. So we say, okay, so what angles would give us a sine value of 1? Let's go take a look at our unit circle. We say sine value of 1. Well, where's the y value equal to 1? That's only at pi halves. So only at pi halves, we'd say then x equals pi halves plus any multiple of the period of sine. So plus multiples of 2 pi. So these would be the solutions. And so very good examples on, well, not the first example, but on how you would use factoring and factoring something of quadratic type to solve trig equations. Enjoy.